Hey, sorry, just technical difficulty, and I got it all fixed now. But here we go. So our debate was which one is it, guys? I hope you had a chance to think it through. It basically is that guy. Okay. Here's why. Because just think about the picture and the connection, right? How come it wouldn't just be x squared? Well, if it was just this one, x squared, that would be literally just basically this guy, right? I need it's this guy, and then I need that part of it. So I need its second dimension to think about the area, right? Another way to think about this, see if this helps, and maybe this isn't, and I hope you're not too lost. But if I have a of x, hold on, I'm gonna let my screen catch up. Okay, just think about how I could build the square, right? What are the dimensions of the square? Well, basically, it'd be output times output, whatever height that is times whatever height that is. So thus, it would be f of x. There's my output times that same output, f of x, right? And so now if I build the square, check it out. It's going to be x squared times x squared, technically, and it's basically just abstract form. Thus, it's going to be x to the fourth, okay? So I can clearly see why it would be that one. And now let's just do some quick math. So here we go. I got 0 to 6. I've got x to the fourth dx. And that will represent basically this. It's the volume of all the squares added together that are infinitely thin. Don't forget that infinitely thin part, right? That beautiful connection. That basically I'm collecting all these squares, but I'm making them infinitely thin and then just summing them all together. Okay? All right. This should be a real easy one. Here we go. 1/5 x to the fifth evaluated at 0 and 6 equals basically 1/5, and I got 6 to the fifth power minus 1/5, 0 to the fifth power. Don't forget to always show the 0. I know a lot of times it does cancel out. There are definitely functions where that won't cancel out, so just keep that in mind, everybody. All right, just clean it up. Oh. So what do I have? I basically have 6 to the fifth over 5, right? And I would let any calculator in the world now handle that. If you, hey, I've been exploring with this thing. If you love math and you're into this, I would get this for you if you know that you're going to kind of follow down math. This iPad app is as slick as could be. It's definitely I'll get the price for you, but it's really nice to do. So there's my integral, and I'm going to go from 0 basically to 6, right? I basically have a nice way to do this. I have x quantity squared, right? And so that would be this. But basically, I'm going to square that, right? dx, and then I'm going to hit enter, and then there it is, right? And let's see, 6 to the fifth power is, there's my numerator, right? So basically, if I had 6 to the fifth over 5, I could see the direct connection. This is just the TI Inspire. It's a wonderful app that you can get on basically an iPad, and I've fallen in love with it. It's pretty slick on how it works. It basically can just zoom in, zoom out. Basically, I can show you 0 to 6. I can even go integrate, right? Analyze graph, and I want basically integral. And I can just take my finger and I can put it on 0, and then I can go basically to, where's 6? 1, 2, 3, 4, 5, 6, right? And I can even just test that bound. What are the coordinates of it? It would tell me. As you can see, I'm not quite at 6. And then the 69.7 is actually the area. That's the area of 0 to 5.49. This thing is just slick on how it moves. And then basically it has the feature of I can go between that and my graph and my calculation. So I'll let the screen catch up here in just a second. I opened up the window. Sorry, the internet's kind of, sometimes good, sometimes bad. So even making this video is a little tricky. But we'll do the best we can from it. So looks like it froze, but it's all right. Hold on, let's see if we can get back to Notability. Pop it up there it did. So sorry, there's just a little lag to it. There we go. Okay, so To keep this video not too long, nice and concise, the idea is basically what we are doing is we're going to what's called perpendicular cross sections, and I'm going to build all sorts of different geometric shapes. Okay, so here we go. So let's have my axis, right? I'm going to do this lightning fast. There's this. There's my x, right? And basically, I got basically this, and there's my x squared. I'm going from 0 to 6, right? And then there's 0 to 6. All right, okay. So what I'm going to do is I'm going to keep referring to this as the slab. I'm going to make that little slab, and I'm going to make a shape out of this, right? We just did squares. Let's make this an equilateral triangle. What would that look like? Okay, that means this. If I draw this, let me try to do this for you. Watch this. So the equilateral triangle would look like this, okay? Geometrically, every side would be congruent, so we'd mark it like that. The catch is this. This guy is that. And there's my learning for you, is that basically f of x is determining this. So that's f of x, that's f of x, that's f of x. Now, let's just make infinitely thin equilateral triangles and sum them together. So I go from 0 to 6 of this a of x dx, right? Now, what is the area of a triangle? All right, so the area of a triangle is a half times the base times the height. Area of this thing would be 1/2. The base, which is going to be this guy right here, is this slab right here. So I got you. All right, so base, you're basically just x squared, all right? That's what you are. You're basically just whatever the output would come from, wherever I am. Okay. What's the height? Oh yes, should bring back memories now of freshman geometry. I hope. All right, the height of a triangle has to be perpendicular to the base. So to find this height, I have to be perpendicular to that base. Thus, it's not just f of x. I'll have to do some investigations. So here we go. I'm going to just clean it up real quick to give us a beautiful picture. So I basically need to know what is that perpendicular height. Here we go. Watch this story. That's a 60-degree angle right there. That's 60 degrees. Again, that's 60 because it's equilateral. And every angle then inside that triangle would be 60, 60, 60, bringing you back to the famous theorem I taught you when you were a freshman, that triangles add up to 180. Okay? And every angle would be the same. Okay. If that's true, that makes that 90. Then that makes this 30. And I have the very famous 30, 60, 90 from trig, right? Interesting concept now. This would be the perpendicular bisector, okay? So I know this leg is actually f of x. This leg would be basically half of f of x. Now, to find the height, watch what we do. We go back to a very famous ratio, s, basically 2s, and s root 3, okay? That would basically be in a 30, 60, 90. Let me do that in a different color just so it's St. Patty's Day, let's do green. So I got S root 3, and I got twice S, which makes sense. Let me show you why, I hope. If this is 1/2 f of x, double that, and you'd get f of x. So there's the relationship between s and 2s. So if 1/2 f of x is the s, this thing right here, it's this thing right here. So what would be the height of this triangle to get us back to the whole story of the problem? Thus, here we go, the height of this triangle would be 1/2 f of x root 3, or root 3 over 2 f of x. Now, what is f of x? Oh, f of x is x squared. Oh, okay, sweet. So what does that mean? That my height is this thing. And I'm going to just put it all in terms of x. So I've got root 3 over 2 of x squared. And voila, look at this formula all come together right here that we're focused on. The area of this triangle would basically be 1/2 times root 3 over 2 times x to the 4th. What is that going to give me? That's going to give me root 3. I want a sharper pen. Sorry, hold on, because I'm zoomed in so much to make this really clear for you. Okay, root 3 over 4 x to the 4th. And what this just did is, here's a huge moment for you guys. What is that? What truly does that represent, right? And I hope to give you just an idea. I'll give you a second, almost like a wait time if I'm teaching. So again, the question I'm after is, what does this represent now to the whole context of my story? Can you put it all together, right? I'll just kind of give you a second. It shouldn't be too hard to follow because I called this A, right? And basically what I hope to understand and show you, this thing is this guy right there. So if I would go from 0 to 6 of this thing and just plug it right in, it's going to get it right for me, okay? Which isn't too bad to think about because a lot of you have gotten so good at this, you've recognized scalars, right? So 0 to 6 of root 3 over 4 x to the 4th dx. 0 to 6 root 3 over 4 x to the 4th dx. That looks familiar. I'll let my screen catch up here just a second. Sorry. So that looks really familiar because I'm pretty sure I just did a square, and the square was from 0 to 6 x4 dx. Stupid screen. It's okay. If I go back up to my little square calculation, oh, there it is. Wonder what the connection might be. Is there a pattern? This is what mathematics is all about. This is where it's not just about learning calculus, but it's realizing we just did a whole different shape. And basically, I can see that this was the same as the square, but all that is now is there's this thing out in front. So wonder how this is all interacting. And yeah, I'm alluding to something. There's definitely a shortcut, and it's just going to be a recognition of pattern, right? And I want you just to understand that basically that there's going to be a neat idea that, I'm going to understand what the pattern is. And then if there's just a shortcut to take instead of calculating each shape over and over and through. For instance, fun moment. Let's go a whole different color now. All right, we're going to go pink. What if I made this like a right triangle like that? And thus, this would be f of x, this would be f of x. There's my 90. What if I made those all my perpendicular cross sections? So kind of neat to see what this would look like, right? I've got another one look like that. And there would be this f of x, and then this f of x, and then there's my 90, okay? Think about all these different f of x's now that would form, all right? So let's just do a real tiny one. So that would be like this, that would be like this, there would be my right triangle. And this right triangle would be, there's my f of x, and then there's my f of x. Pretty neat to see that, okay? So what would that be now? Well, we'd have to go through the whole formula again. Area is a half times the base times the height. And then I'm looking at a triangle that looks like this. It's f of x times f of x, right? So real interesting to see the connection. No problem. This base, this guy right here, right? This height, this guy right here. I've got that base, I've got that height. Interesting. Area would be 1/2 times x squared times x squared, which the area of this would be 1/2 times x to the 4th. Oh man, integrate from 0 to 6, infinitely thin right triangles. 1/2 x to the 4th dx. Oh, half 0, 6 x4 dx. And now all of a sudden, I'm seeing a massive connection. Look at this. So now let me just show you. This was for an equilateral triangle. This, I forgot, it's okay, would be for a right triangle, right? Then I'm going to scroll up and I'm going to grab this guy. Sorry. And then, technology fail. Don't worry. I'm going to get good at this, guys. You just wait. This would be for a square. And what pattern do I see emerging? Next video, I'll show you the pattern, but this is the intro. Welcome to Virtual Learning. I hope all is well. Send my love. You guys are dearly missed. Today's a very good day for us Irish people. Today's St. Patrick's Day. My father is Irish to the T, as we say back home. So today we're all Irish, and today we give hugs and celebrations, although we can't do it. Here's a virtual hug. I'll send you another video. We'll keep going like this. You guys can send me questions. I can give you video responses, and we'll start building our world together like this. There's pretty fun. I mean, hey, just enjoy what you got, right? And we'll make the best out of it. So hope you guys are doing good. Definitely love sent, and happy St. Patrick's Day.